Hi everyone. So I'm just continuing from where I left. Uh, this is going to be the second part of weekly live session number three. Uh, I mean, you know that somehow the Apple Pencil stopped working, so I've actually fixed that issue now. Uh, yeah, so I will continue. So we were in the triangular channel section. We're trying to find out the critical depth and the corresponding specific energy for a discharge of 5 meter cube per second in the following channels. We were in the part B. So YC is found out as 1.83 meter. So let us just move and solve the next part. The critical energy, as we found out, was 1.25 times Yc for a triangular cross section. So it is 1.25 times 1.83 meters is equal to 2.29 meters for a triangular cross section. Now the third part is about the very much anticipated trapezoidal channel, because many people were actually asking questions about the the trapezoidal cross sections. So let me just make a trapezoidal cross section. It would look a bit like this. Let us suppose the depth of the flow is again y. This is the side slope is 1 is to m, both the at both the sides. So this part would be m times y, and this part will again be m times y. Okay. So the top width happens to and the base, that base happens to be b. The top width happens to be base plus 2 times my. It's very simple to understand. And the area will be nothing but half of the sum of the sides, half times sum of the parallel sides times the height. So half sum of the parallel sides means b plus 2 my times the height. Height is nothing but the depth of the flow. So it is b plus my times y, the area. Now we will just go back to the generalized expression. So that was q square by g is equal to ac cube by t. So that was a generalized expression. As I told that in case you don't remember anything, you just go back to this general expression for critical flow. So this would go give us q square by g is equal to a is b plus myc a cube, so myc cube times yc cube by t, and t is b plus 2 myc. So just put the values. Q square by g is 5 square by 9.81 equal to 2 plus 1.5 yc whole cube times yc whole cube by 2 plus 2 into 1.5 yc. So by solving this equation, we will get by trial and error the yc is equal to 0.715 meter. That is a critical depth for a trapezoidal section. Now we need to find out the critical, the velocity with respect to the critical depth. That would be equal to q by a. We don't know a yet, so q by ac. We don't know ac yet, so ac would be equal to uh, AC would be equal to B plus MYC times YC. So it would be 2 plus M is 1.5 times 0.715 is YC times 0.715, which is 2.2 meter square. Let's move to the next slide. So VC is nothing but Q by AC, and that would come to be 5 meter cube per second by 2.2 meter square. So that would be 2.27 meter per second. So the critical, energy would be nothing but Yc plus Vc square by 2g for a trapezoidal channel, and that is Ec is equal to 0.715 plus 2.27 square by 19.62, 2 times 9.81, so that is 0.98 meters. Let's move to the next question. It is a rectangular channel 2.50 meter wide has a specific energy of 1.50 meter when carrying a discharge of 6.48 meter cube per second. Calculate the alternate depths and corresponding Froude number. Okay, so the given width is 2.50 meter, the specific energy is 1.50 meter, and q is nothing but 6.48 meter cube per second. So the specific energy, I mean, if we don't know anything, then just go back to the first principles. The specific energy can be presented as I mean, the total head when we take the channel bed as datum. So it is y, the flow velocity, flow depth plus the velocity head. We are just assuming alpha to be 1. So that is y plus q square by 2g a square, because v is nothing but q by a, equal to y plus q square by 2g b square y square, because y a is equal to b times y for a rectangular channel. So just put the values. 1.50 meter is equal to, that is e, is equal to y plus 6.48 meter cube per second a square by 2 times 9.81 times 2.50 square times y square. So you just solve this expression. The expression would come out to be y plus 0.34243 by y square. Just solve this equation by trial and error. You would get two values of y. Y1 will come out to be 1.30 meter, and y2 will come out to be 0.63 meter. So these were the alternate depths, and we have to also find out the corresponding Froude numbers. So let us just find it out. Yeah, for that we would need another slide. So the Froude number would be V by G times A by T. By now you are very familiar with this expression. So V can be represented as Q by A can be represented as B times Y for a rectangular channel, and top width is nothing but the width. So that is B. So this happens to be Q by A is By times square root of Gy. So the Froude number will be 6.48 meter cube per second by 2.50, that is the width, times y times 9.81 times y in the square root. So this is Froude number is can be represented, simplified as 0.828 by y power 3 by 2. So we know y1 and y2. You just put the numbers and get the Froude numbers straight away. Y1 was 1.30 meter, so the Froude number corresponding to that would be 0.828 by 1.30 power 3 by 2 equal to 0.56. So the Froude number is less than 1. So this would mean this is a case of subcritical flow. Y2, the other alternate depth, was 0.63 meter. So Froude number corresponding to that would be 0.828 by y2 power 3 by 2, that is 0.63 power 3 by 2, and this happens to be 1.67, which is greater than 1. So this is a case of supercritical flow. So this also kind of answers the question which was asked in the live session, that what would happen. I mean, is the higher depth corresponding to subcritical flow or supercritical flow? Yeah, the higher depth is corresponding to the subcritical flow, whereas the lower depth is in usually, I mean not always, but lower depth is corresponding to the supercritical flow. I mean among the alternate depths. So let's move to the last question of our class today, live session today. A sluice gate controls flow in open channels. At sections 1 and 2, the flow is uniform and the pressure is hydrostatic. Neglecting bottom friction and atmospheric pressure, decide the velocities V1 and V2 and the horizontal force F required to hold the gate if H1 is 6 meter, H2 is 1 meter and B is 5 meters. Okay, so the diagram for the question would look like this. This is the sluice gate. This is the upstream, This is the channel bed, and this is the downstream. So let us suppose we have two sections, section 2 on the downstream and section 1 on the upstream. So let us suppose this height at the flow depth at the upstream section happens to be h1, and the corresponding flow depth is h2 at the downstream section. Velocities are v2 and v1, which is quite understandable at v1 at section 2 and section 1 respectively. So it's a sluice gate. First of all, sluice gate with width of b. So what to do in such questions? Such questions are very different, and that is why these are very different categories of questions, and that is why I actually plan to discuss it in today's class. So first of all, while solving this question, first of all we need to choose a control volume. Step one: choose a control volume. Otherwise, solving it is very hard. Such questions. So we will take another slide to explain that. So the step one is choosing a control volume. So let us just redraw whatever was given in the problem. This was a sluice gate. Yeah, and in order to keep the sluice gate at its position, there is a force F in the original problem, and we need to find out this original horizontal force F, which is required to hold the gate at its original position. So yeah, so coming back to the question, the sluice gate would look a bit like this. I'm trying to draw the control volume here. This is the channel bed, okay, and this is the upstream. So this is section 1 and this is section 2 as was discussed in the question. Now let us just take a control volume. So this is the control volume which I am taking. I'm trying to make it a bit bolder just for uh, a good visual representation. So this is the control volume. This horizontal force is required to keep the sluice gate at its own position. And there are two hydrostatic forces acting on it. The first force is downstream, and it is rho g h2, the pressure. The other one is upstream. It also acts like this, rho g h1. So we are just considering the gauge pressure, and that is why it's zero at the water surface. The question already states that the shear stress, yeah, bottom friction is to be neglected. So that is what we are writing. Tau is equal to 0. So that is what we know by now. We have drawn the control volume. Now let us take the step 2. Move to the step 2 in the question. Inlet and outlet mass flow balance m dot is equal to mass per unit time can be written as this, which can be printed as rho q as we discussed in the previous class, which is rho v times a, because q is v times a. We will take another slide. Finally, finish this question. So m dot is equal to rho va, which we discussed in the previous slide. So for the upstream section, it will be rho v1 times the area there, that is h1 times b, and for the downstream section, it will be rho v2 H2 times B. So from there we get V2. From these two equations we get V2 is equal to H1 by H2 times V1. So let us suppose this is equation star. Now step 3 is about balancing the forces. So we just use the Newton's law. So that explains that net in the horizontal direction, net horizontal force can be expressed as x direction momentum change, and we take x in the right hand side to be positive, x positive to the right hand side, to the right, that is this side is positive. So the net force in the x direction happens to be minus F gate, force required to, I mean, hold the gate at its position, minus why minus, because it's from right to left, minus F gate plus the pressure times the area at the upstream, that is 1 minus pressure at the area at area at 2, why minus, because it's again at acting from right to left direction, which is equal to the change in the rate of change in momentum. So that is m dot v2 minus v1. So minus f gate plus, so p1 can be represented as the area of the triangle there, this triangle. So the area is half into gamma is rho g into h1 time, so this is the pressure so far, and times the area is h1 times b for section A. So this is pressure and this is the area. Minus for P2A2, it can be similarly written as gamma H2 by 2 times H2B equal to the change of momentum, which is H1 by H2, V1 minus V1. We just replace V2 with the expression star. So we'll take just one more slide to finish the question. Yeah. So we just need to solve for F gate by eliminating V2 from the expression using equation star. So we finally get F gate equal to half rho g, that was gamma, B h1 square times 1 minus h2 by h1 square minus rho h1 bv1 square by h1 by h2 minus 1. So this will be the expression of force, horizontal force used to keep the sluice gate at its own position. However, there is one problem with it. V1 and V2 are still unknown. I mean, V1 and V2 are still unknown in this expression. We need to find either V2 or V1 and then substitute in this expression. So in order to do that, we have to follow another step. So we basically apply the Bernoulli's equation. Apply Bernoulli's equation for 1 1 and 1 2 at free surfaces, at their free surfaces, so that the pressure term vanishes because it would be zero, it is atmospheric, because we are considering the gauge pressures. So it would be P1 by rho g is nothing but gamma, plus V1 square by 2g plus H1 is equal to P2 by gamma plus V2 square by 2g plus H2. So this P1 and P2 term will be zero because we are taking it at the free surface. So we try to eliminate V2 using equation star. So we finally get V1 is equal to 2GH2 by 1 plus h1 by h2. So h1 by h2 in the question was given as uh, h1 by h2 is 6 meter by 1 meter. So that would be 6. h1 by h2 is equal to 6. So this implies V1 can be found as square root of 2 9.811 by 1 plus 6. So that would be 1.674 meter per second. V1 we know, now V2 can be found out from the expression star H1 is to V1, which is nothing but 6 times 1.674 meter per second equal to 10.045 meter per second. And F gate, the force required to keep the sluice gate at its own position, just put all the terms in that in the boxed expression, you will finally get the F gate to be 437 kilonewtons by substituting the values. So that's it. That's what I wanted to discuss today. Sorry because of the malfunction, but I will make sure to upload this YouTube, video also, recording also in the YouTube channel. Thanks a lot.